Dr. Paulraj, Associate Professor, Department of Mathematics, Ahmed University. Today we are going to discuss vector integration. In the part of vector calculus, one is a vector differentiation, another one is a vector integrations. So in the vector integrations, what we are going to discuss? Use this concepts, we can find line integral, surface area and volume. These three things we can find by using the vector integration concepts. So the first one is line integral. So how we find the line integral, and through the line integral one can find the work done by a force. So first we will see what is the line integral. So in that vector integration, the integral is evaluated along a curve is called a line integral. So let capital C be a curve in some region of a space described by a continuous vector valued function. So that is described as R vector. So R vector equal to xi vector plus yj vector plus zk vectors. So that is the vector continuous vector function. It is the R vector. Now let f vector equal to f1, the function of x comma y comma z. So f1 I vector plus f2 j vector plus f3 k vector be a continuous vector valid function. So defined in some region which contains the curve C. The line integral f vector over C denoted by integral over C f vector dot dr vectors. So that is denoted with the integrations. So this line integral are used to calculate work done by ocean currents on floating objects. So this line integral helps in tracking the drifter paths or modeling pollutant dispersions. So in the marine field. So this is the concepts used to find out the work done and tracking the drifter paths or modeling pollutant dispersions. The next one, surface integral. The vector integration, the second concepts. Surface integral. An integral which is evaluated along a surface is called a surface integral. So let S be a two-sided surface, and let us take one side as a positive side. Let f vector be a vector point function defined at all the points of S. Let ds be the elementary area. So ds be the elementary area, and the n vector or n cap be a unit normal vector to the surface. So in that we take the theta be the angle between the f vector and unit normal vector n cap. So the surface integral, the integral of this normal component through the element surface area ds. ds is the surface area. So over the surface S is called the surface integral of f vector over S, denoted as double integral. So in the surface integral we use the double integration. Previous line integral we use the single integrations. So in the surface area, double integral S f vector dot n vector ds, or simply integral over S f vector dot ds vector. So surface integral are used to measure how much water or air flows through the surface, net water transport through a straight R pipe. So this concepts used to measure the airflow or water flow in the transport through a straight pipe. So this is the purpose of surface integral. The next one is a volume integral. So an integral which is evaluated along a volume bounded by a surface is called a volume integral. So let the volume capital V. Generally all the authors denoted the volume as V, capital V. So let the volume capital V be bounded by a surface S. Let f of x comma y comma z be a single valued function. The volume integral of f of x comma y comma z over V and is denoted by triple integral V f of x comma y comma z into dot dv. Okay, so here we use the triple integrations. So line integral is the single integration, surface integral is the double integration, volume is the triple integrations. So this concepts used to calculate total mass, heat or salt content in a 3D section of the oceans. So this is the way this concepts used in the marine field. So this is the what is the one example. We'll see the one example in the marine field by using the line integral. So what we are going to calculate? We take the one scenario. So in the marine field, work done by a ocean currents on a drifter. A floating drifter moves along a curved path C in the ocean under the influence of ocean currents. The vector field F vector represents the velocity of the ocean current. At the point in space, we want to calculate the work done by a current and the drifter as it moves along a path. So one example here given, let ocean current vector field F vector, that we take it as a 2yi vector plus 3x j vector. Here the path C as a, we take it as a quarter circle. Quarter circle means the x value from 1 to 0, y value is 0 to 1. So that is denoted here 1 to 1 comma 0 to 0 comma 1 of radius 1. So here we take the parametric form. X value is a cos t, y equal to a sin t. Here a is the radius value is 1. So the t is in between 0 to pi by 2. What is the dx by dt? X equal to cos t, therefore dx by dt equal to minus sin t. Y is the sin t, then dy by dt equal to cos t. Then the f of x comma t, y comma t. The f vector equal to, instead of x you put the cos t, instead of y you put the sin t. Over here 2yi vector. So y value is a sin t. So 2 sin t I vector plus 3 cos t j vector. Then f vector dot dr vector. How to calculate the dot product with the f vector and dr vector. Dr vector is a r vector differentiations. So dx by dt I vector, dx by dt y vector. So now f vector dot dr vector equal to 2 sin t into minus sin t plus 3 cos t into cos t. That's equal to, we get the value minus 2 sin square t plus 3 cos square t. So if you calculate, we get the w, that is a line integral or work done by a force, integral 0 to pi by 2 minus 2 sin square t plus 3 cos square t dt. So in that, there are the two things we have, the identities sin square t and cos square t. We substitute the identity values here. Sin square t is a 1 minus cos 2t by 2 and cos square t is a 1 plus cos 2t by 2. If you substitute this value in the integrate, we get the w equal to integral 0 to pi by 2 1 by 2 plus 5 by 2 cos 2t dt. So now integrate with the limit 0 to pi by 2. The lower limit is 0, upper limit is a pi by 2. When you apply this limit instead of t, because we are integrating with respect to t, so we get the value w equal to pi by 4. This is the work done by the ocean current on the drifter as it moves along the curved path. So here we are finding the work done by the ocean current on the drifter in the path. So that value we got is pi by 4. Thank you.